So first thing is the easiest thing to do, which is just show the custom assets in my map. So the basic idea of this game is I just kind of thought I made these two platforms, and I just kind of thought it would be funny. What if it was like a board game, but like you had to throw the pieces onto the board, right? So it's just like really annoying. And so, however, that's why we have the two platforms and these pieces, but that was kind of incompatible with like any of the objectives that were assigned. So I didn't implement anything like that. And instead, we have, okay, but these are my assets. I have these images, I have these sound files we'll get to later, and then I have this GIF that you're gonna see that right now. And I also have my script objects in their own folder. Okay. So, turn my music down. Sucky. Okay. So, first thing, boot up the game. Nothing here is moving, okay. And so, this is a little object I made to fulfill a bunch of the requirements. This is the GIF. And it moves, it chases you, and it's so scary. And then, so you press the 1 key on the keyboard, and it spawns another one. And it's really laggy, but that wasn't a part of the objective. And then when they get really close to you, they stop moving. And then you can delete them. Okay. And so basically, this fulfills a bunch of the objectives. A guy that follows you, all sorts of stuff. Okay. So, and then, I have to prove that I know how this stuff works. So I have to open up, this is the code for the Ame. Her name is, sorry, this is the code for the little image that's on the image plate, and it chases you around. So I used self here. I didn't want to, this is the first thing I coded, so I didn't want to use the default values. I just made a self thing. So what this is going to do is, this is the code for it moving, all right? You'll notice that it uses delta seconds and a variable speed. The way I face it towards the player is I used find look at rotation. And that's how you'll notice that it doesn't actually go face towards the player because you can move your camera up and down. And I disabled that intentionally because I wanted to. So this vector is like a direction and a length, basically. So you can use a vector if it's like values between 0 and 1. There are a lot of different things you can use a vector for, right? But one thing you can use is for direction. Okay. And so this, and you'll notice that, so this vector is the movement. So this is the direction. It gets it from here. And then the movement itself is the speed variable in delta time. And delta time makes sure that it keeps moving even after it keeps, so delta time is like a number. This is like how many seconds have passed since the last frame, right? So if you just multiply the speed by the delta time, then this speed variable would be how many units you want it to move in 1 second. So I chose 60 for that. Okay, so you might be wondering how it gets the location of the player. I thought the only way I could figure out how to get the player was get actor of class, and then I would do find nearest actor. That's fine. And so, but that would be kind of inefficient to run every frame. So that's another use of variables. One use of variables is to set these default values conveniently. Another use of variables is to not have to do calculations every frame. You just do it once at the start. So that's why this is at begin play. So now we have the target variable that it uses in find look at rotation to set the actor's rotation. And so this is a variable, I'll talk about that later. And so yeah, it just sets the actor's location. So I'm gonna explain that right now. It moves it, basically is how that works. Okay, so so now here's how the collision works, because there is collision here. When it gets near the player, it will not collide with the player's camera themselves. there is actually a funny little object called the player collision blueprint. So you'll see that this is invisible. If you turn it on, you can see what it does. So it's like a little cylinder. It stays at the same X and Y as the camera. And when she touches this cylinder, she will stop moving. So that's what that does. And then we'll explain the spawning in a bit. So basically the cylinder has the tag. It has the tag for player collision. And so in Ami's code here, we have event actor begin overlap. If the target has the tag player collision, then it sets this moving variable to false. And that's another use of variables is booleans, you know, a very important thing for variables. So this is what the branch is used up here to disable its movement at the last step. Because the reason we disable the movement at the last step is so that it still rotates properly. Or wait, no, it doesn't rotate. Wait. No, it does rotate, I believe. I believe it does rotate. Okay. Wait, does it? God damn it. Oh no, I swore. It's so over for me. So, this is the event graph for this guy. So now my collision guy. One of the principles of object-oriented programming is that the objects should know like as little about each other as possible, right? Whatever information they need. And the code in this guy you can see is very straightforward. You just need to know the location of the player. And then it can use that. And then this is also, you know, just in case I change the height of the platforms. Yeah, so this just places the guy. It doesn't. You don't need delta seconds for this because we just want it to teleport, right? It just needs to be accurate to the player's location at all times. So there's no reason the delta location for this. Okay. And another thing about object-oriented programming that this represents is how objects should be like relatively. You want to try and make them independent from each other in two ways. You want to make them not take too much information from each other, and then you also want to make them not modify other objects when that other object could be modifying itself, you know? So all of the code in these guys is like completely self-contained, and the only time the code in these guys interacts is when they collide. All right. So now it's time for the spawning and deleting functions. So how this works is, so if you press 1, it spawns it, and this is using the button pressed event, right? I forgot to set the guy invisible, but it's fine. So then, if you press shift and 1, it deletes it. You can have as many of these objects as you want. You can just make a billion of them. Oh, I touched the Trinity box. Ignore that. So just spawn a bunch of these, and then it'll still be able to delete all of them nice and cleanly. Okay. So, how that code works is, let me Control Z. Now it's invisible. Okay. All right. So, when it comes to spawning these objects, this is another important thing for object-oriented programming, is that things should only have the abilities that they would logically have, you know? Like, this object would only be able to do this thing. Ame would only be able to move. This would only be able to follow the player. Nothing should handle the spawning for a different thing. And so I could have put this input thing in the player, but this isn't like an action that the player is taking. This is more of like a system action or whatever, you know? And that's what I decided. Because the player realistically wouldn't be spawning these. So, this is the input event. And then we also have the is shift down, which is the other type of input event. So I have both of them right here. And so basically what's going to happen is this is actually a bug fix. This part of the code is a bug fix for a bug that doesn't happen anymore because I fixed the actual problem. So basically base spawn position is a variable. This is why they all spawn in the same spot. If I ever wanted to have them spawn in different locations, I could add or subtract from this. That's another thing variables are good for. So if one is pressed, shift down is not pressed, then it's going to spawn the guy. And what's important here for deleting all of them is that it puts them into this array. And so if shift is down, then it's going to go up here, make sure that the array isn't empty, because I was getting some weird stuff to happen. And then it will destroy all of the ames in the world, in the whole world. So be very careful. This is a very powerful function. You want to be careful with this one. The final thing, I'm sure you heard it make a weird noise. It was quite strange. I'm sure you're desperate to know more about Platinum the Trinity Cube. All right. So the other collision uses overlap collision. Okay. And so this uses hit collision, which is whenever something makes contact with it, there's like an instant collision hit, and then it'll do a thing. And so what this is going to do is play a voice line from Platinum the Trinity in the hit game BlazBlue Central Fiction. So basically, they can go over each other, but it doesn't, if you just rub up against it, it isn't going to like go fucking crazy. And so basically I was having this problem where you would touch it, but you would rub up against it really weird. So what I did was I made it I made a little cooldown. And so final piece of code. I won't spend too long on this. It picks a random number. You can see there are 6 different sounds, so 0 through 5. And then all of these sounds are hooked up to a switch statement. But anyway, so that's Platinum the Trinity. And then she's awesome. She's like a cube, and she goes like Dramaticosemi, or like Trinity Box Soup. And then another important thing while I explain this. Is that Ame can play with her orb. It's an important thing. So you can actually see the delta time here. It's moving substantially faster. And then we can see in the delta time, now she will play with her orb. Very awesome, very physics. So, inheritance is the idea that you have a parent object and all of the children that inherit its properties. Can see this little platform is the parent. This little checkerboard pattern is the parent. And all of these are all children objects. And so you can see when you move the parent, all of the children will also move, even though they are not necessarily one object.